that is called a grid compliance study, right? Compliance or grid interconnection studies. Anything we are going to do that, but we are going to grid compliance study. So almost everything is almost same only. So especially whenever we are moving on to the renewable sector, now it is quite demand, right? I hope so. So yes, so I will take an Excel first. Yeah. So first, basic introduction. So introduction. Okay, today. So how I'm going to go for the methodology and then how we are going to discuss. So first of all, which software? There are three softwares we are going to do. So with respect to the software, so I'm going to concentrate on first on PSSC, then second on PSCAT, second on PSCAT, and third on ETAP. Okay. Why I'm going to give some least priority of this particular ETF software, because usually we are going to concentrate on important study. Majorly, we are going to concentrate on study called grid compliance, grid compliance study, or else connection study. Anything we can say. Okay, grid connection studies or grid connection studies. Right? We can able to say grid compliance study or uh, grid compliance or connection studies, anything. And so in this as per the grid compliance or connection studies, most of the utility is going to be an expect on PSS and PSCAT. And some studies we can able to cover up and ETAB also. So we can try to cover up by using by the, so that's the thing we can able to do that. So yeah. So why we need to do this grid compliance study? Why we need to go for the, in any idea about from your perspective point of view, why I need to proceed this particular study? Why I need it? What is an importance of this? Anybody have an idea? Means we can suggest or else I will tell. Yeah. Any ideas or any suggestions?
Yeah, so hi, this is Barun. So we do the grid study for the renewable generator, especially to understand that whether the addition of the generator will ensure that the grid is stable in case of unforeseen incidents such as like low voltage right through or high load, low generation, and vice versa. That is one way. And apart from that, we would like to also understand that what is the requirement, or we can say the reactive power compensation,
Mm-hmm.
or reactive power that can be injected or taken from the grid, so that the various parameter of grid is maintained, and so as not to have a mass blackout or instability in grid. Let us say it may or may not result in over frequency if we are not thorough with our system studies.
Exactly. Very
And
good.
yeah, apart from that, we can do like the SCR
Mm-hmm.
estimation as well. Like what is the impact of SCR
Wow.
based on the whole what do you call it, local grid conditions, and
Mm-hmm.
so on. And the list
Mm-hmm.
continues. Yeah.
That's lovely. That's lovely. Thank you. Thank you, Varun. Much appreciated your efforts on this particular thing. I think almost you have covered some basics on the technical side. It's very good, actually. I'm impressed. Thanks for that. And so, yeah, as per the Varun said, so there are two things we can able to say. That is, first, most probably we are going to analyze the system strength. Okay, that's the major thing. That is the first thing we need to understand the system strength of the network, how it will be there. So that is one type of study. Suppose if the strength is good, we can able to connect for the further precedence, means then they will go for the further studies in order to avoid the blockout of the grid. That's it. In order to safeguard the grid. That's it. There are two major reasons. So, but why I need to do those studies means there are two things, but for the same thing. So, suppose if you are the plant owner, maybe in the this is technical perspective point of view. If you go for the commercial perspective point of view, what they will do nowadays, nowadays the demanding is more high. Every country is moving on to the almost the renewable sectors only. For example, if you're taking in Australia, almost they have put almost 50% of renewable. They have converted to 50% of renewable. They have converted almost, and they are now going to trying to go for the storage perspective point of view. They are moving on to the best sites and US markets also. You can think about it, and they are also almost taking off a lot of projects into that for the converting the renewable sector. Almost they have done. And Indian utility market, I think I'm not sure how they are strong on this particular renewable sector, but they're trying to move. They're trying to convert into the lot of renewable energy renewable resources in order to avoid the demands also. Because for example, I was into Bangalore. Now currently I'm in Chennai, but where Chennai does not have that much power on summer side. So we are facing a lot of power shutdowns and all in Chennai. I can able to see that. But previously, in some time, so even though we do have a lot of resources, but still we are struggling a lot into the non-renewable. So there we need to more amount of demand still, because the demand is more high. So again, if you go for thermal means, it is not sufficient. We need to have a lot of spaces, a lot of things is there, and it is not that much good also in the future. So everything is moving on to the electric side, even vehicle and all moving on to the electric side, electric perspective point of view. So simply said, the power demand is very very high whenever day to day life. That's it. Year by year, it's very very demanding, very high. So 95 mostly we can try to convert to renewable as much as possible. If not, there is no other way. We have to go for that. But so for nowadays, then what they will do? Then government is not having in that sufficient money to do that, so they are giving to the private owners. So like I think most of the people from India, then Tata Power and Adani Powers are all coming into the picture. So they are contributing to convert into the renewable side. They are trying to invest money. So what is the purpose of investing money on this particular renewable sector, renewable resources? So they are trying to contribute to the India, and as well as to supporting to the government. That's it, to supporting to the government. So if you do that, then what he will do? He can able to generate the power. He can give the power to the government. Then government will pay the money to the prospective owners. Okay. So even you are also having a money. Just implement it. Put a plant. Even 1 megawatt, 2 megawatt, 5 megawatt plus whatever you can able to contribute through solar. You can able to put and give it to the money. Give it to the money to the sorry, give the power to the government. Then government will pay the money. So then what is the meaning? The government is going to give a money to you to get the power. So if you want the means, then government is our customer. Like for example, the power grid is our customer. So our customer, how he wants and power, in that way we need to give. How the things that he want, that we get, that is called utility requirement. So what is his requirement? What is their requirement? Based upon that we need to do. So this is that requirement test, or that thing is called a grid connection studies. Now I'm just going to put a plant. I'm just going to connect with an grid. So that is called grid connection studies. That's why we are going to do that. That is grid connection. So is their requirement we are going to do in the simulation side. So we do have they do have a three different steps they do have usually. The first step is called simulation study. We need to do the first simulation study. Then second step is called testing. Okay, that means once the simulation is approved, then we have go for commissioning, and third step is called testing. So that means your simulation result and your testing result should be matching with each other. So it was done, then it is fun. So now what we are going to do? We are going to do this first phase one. Let us cut there. Maybe this is phase one, or maybe phase two, or phase three. Let us consider there is no phase three. So what we are going to do? What is I am going to do? I am going to do the simulation study until it is get approved. I will be the responsible for the first phase one. After it was done, after then my job is done. After that, the commissioning people and testing engineers are will taking care of that. Suppose whenever they are doing some testing, at the time it is the output is not coming properly, then again the loophole coming to the phase one people. So this is usually it will happens at anywhere. Previously the simulation was the concentration towards the simulation was less. Nowadays we do have a lot of simulation softwares like ETAP, PSS, CPS, CAD, digital and factory. Everything we do have having to perform any kind of studies in the fastest way, because the computer applications has been increased a lot. So that's why utility people first prove it whether it is possible or not. Then you can come in for the commissioning. Previously it was not that much. So nowadays it can do. So most probably the grid connection studies and the requirement will be able to start almost 2009 or 2010 like that. Now it is booming a little bit. So as of my understanding, 2009 or 2010 it was started to go through the we can able to how we can able to do the studies and all. They have started at 2009, and now it was in the booming state. That way in around almost yeah, almost 11 years. Okay, almost, sorry, not 11 years, almost 15 years. Yes, almost 15 years. They have, after 15 years, it's quite, nowadays the owners are coming because to get the money. That's it. So hereafter, what will they will do once the generation was fixed, then the people will moving on to the transmission side. So AC transmission to convert to DC transmission, they can able to do. After that, what they will do after that, at next step means now the generation is going on. The next phase, the renewable sector only it was okay. But hereafter we do not have any land, we do not have anything to do that. Then we can move on to the transmission. They will go to the HVDC segments. After that, what they will do, they will go for the commercial test, that is called power economics. Okay, economics. So these are the actually this is how, as of my experience and as of my knowledge, maybe it is a flow. It should be go like this because nowadays there is no more power economics peoples. Power economics means nowadays private people are coming into our picture, right? So once the private people are coming into the picture, yes. Okay. So nowadays private people are coming into the picture. We need to pay the money, right? How we are going to, how we can calculate? Because our power system is a dynamic one. It's not a steady state one. It's dynamic one. So on the dynamic perspective, how we are going to calculate? A lot of things is there. I hope so. After that, HVDC should come to the picture. After that, the power economy should be comes to the picture. So this is how the power system field may go in future, maybe next 22 for 30, maybe 30 years. After 30 years, it's the way to go to there. So let's see how it is goes. Maybe it is there means next phase we have to concentrate on HVDC. That's my observation. So now we are going to do this basic power system studies. How they are wanted to do that, everything will be there in this picture. How are they going to do that? This is how we are understanding this. Are we can going to do that particular case for this particular course? Okay. So yeah. So as per the utility requirement, I did told as per the utility requirement, they are going to having a three different types of softwares. That is called two different types of softwares. One is PSS in PSCAD. ETAP, some utilities may require or may not require. And fourth one is Ditsilent is also they are concentrating, but most probably the Ditsilent will not accept in except Germany, because Germany is only the thing who is concentrating on German markets, Spain markets, okay, Spain or Sweden, uh, German or Spain, okay, mostly German or Spain. That UK markets only, okay, almost I can say UK markets. The UK market is only expecting digital factory software, but apart from that, most other utilities like any other utilities, US markets and Indian markets and Australian markets, everyone is concentrating only on PS in PSCAD. Okay, that's depends upon their level. Why they are using, why they are not using, not that and all we can't able to say. For Germany, them Decent is comfortable for them, so they are using. For PSSC, sorry, for AAM, for Australian markets or Indian markets, PSSC PSK is comfortable for them, so they are using. So there is no differences, but the priority difference. That's nothing matters in that. So, but the PSSC, PSCAD, and Decent both are almost same kind of softwares, but the maybe the methodology might get difference. That's it. But they are going to give the same results only. There is no nothing big in it. Okay. So yes, so we are trying to do this particular thing. This is a very under basic theoretical concept or how the system is works out. Because of these reasons only, we are going to do this particular simulation side. Okay, because nowadays simulation is important. Why I'm saying, because the phase one, without the phase one is completed, you cannot able to proceed to the further steps. Okay, so that's why the simulation takes more important right now. That's why the simulation engineers are wanted. Because of that only, power system engineers are in a demand right now in the power markets. Okay, so commissioning testing people are almost, we do have a lot of people, but simulation engineers does not have that much. Okay, does not have that much. So that's why we are in demand, because in a God's grace, we are the utility people are expecting some simulation results. So that's why we are earning money. So that because of that only I am having a good. I mean, I am also running my life in a good way. Okay, so yeah, because we thought you are getting an up. Once you got an approved, then the things will move very fast. If you are delayed, the things will get delayed. If it means the simulation is getting delayed, then approval will get delayed, commissioning will get delayed, testing will get delayed, and after that energization will get delayed. Everything will get delayed. The client will get angry. That's it, because he is investing a lot of money, so he will get angry. So we need to try to close. P1 is a very major phase, is a very basic step. How much fast you have completing your simulation results and get an approval, that much amount we will get very faster back by giving the sale after energization. So This is the thing. Okay, this is a thing. We are very very basic thing. How the power and money is dealing between the now in the renewable sector. This is how the power and money is dealing in the renewable sector. So we need to move on to that. So here we can try to do this. So now we are going to do this different types of means sorry not different types. We are going to do the grid compliance studies in a different softwares PSSC, PSK, and ETAP. We are going to how to do that. PSSC and PSK is quite maybe in-depth analysis, but ETAP wherever is applicable, then I will tell that particular software. Okay. So now we are not going to consider ETAP. We can consider ETAP in the later stage. Means maybe after PSSC PSK we have completed, then we can consider later stage because it's small things only we have to concentrate. But PSSC and PSK we need to be concentrated a little bit more on this particular software. Okay. So the first and foremost step. Okay. Okay. Right. Now software. Now we have concluded why we need to go for the simulation studies. Okay. We have completed simulation. Now what is the next step? What is our next step? Then we need to do, right? Let us consider, I'm just going to do the PSSC. Let us consider, let's take a PSSC. Okay, first I take this particular study. What is the first step? We need to do that. Okay, so now we can able to come into the conclusion. What is the purpose of doing the simulation studies? Yeah, now what we can able to do the step number one. Okay, step number one in any software, maybe in any software, Okay. Step one. What is the step one? Step one, uh, let us consider maybe I'm going to invest some money in 50 megawatt of plant. Okay, let us consider I have some money. I am just going to invest to generate the PV plant. Okay, going to invest in PV plant of 50 megawatt. I'm just trying to invest. So if then what I will do, I will go to the first any engineering consultancies or else any design teams, any engineering teams, electrical engineering teams, those who are quite good in this particular thing, renewable sector energy, I will going to contact them. Once I have going to contact them, okay, what they will do the first steps, okay, you are going to put 50 megawatt of, then they will design your plant. First, they will design your plant. Okay. Now we are not going to do that. Now where in which step we are coming, that I'm telling you. They will design your plant. In this particular design, for in PV plant, then how many inverters required, how many inverters we required for that, how much what is the transformer rating, then cable, then their layout, okay, then plant area, this and all they will consider based upon this plant area. Everything will they will consider depends upon that. They will think about the inverters and which inverter, which is means inverter OEM, which inverter OEM we can able to contact. There are a lot of manufacturers out there. Which inverter we can able to contact, and any cable layouts, cables and their layouts, and if there is any transmission line required, anything. This is only sizing. Okay, that means simply called everything has been sizing. Okay, transmission lines and this kind of things maybe can be able to come to the picture. Okay, they are giving if I calculate the impedances, they will contact and they can plan to procurement and all. Whether we do have how much cost it will then. So then based after that, okay, after that step one, step two. Once it was get approved by the client, then step two will be coming to the power system engineer. Power system engineers. So power system engineers, what can that is we need to do the simulation studies now. Now we are in a phase two, now in a step two. So once they have finalized everything, they are going to giving to me. Then based on that, I will go for these simulation studies, like basic, very basic steady state, very basic steady state will perform. I'll perform the steady state analysis. And then based on that, okay, everything is okay. We will proceed as per their requirement. So once it was done, I will confirm that. Then they will do that. So once everything was finalized, then only I can able to go for the further studies, further detailed studies, further detailed studies. Detailed studies. This is called. This is in here will come load flow, short circuit, then reactive power compensation studies, and if anything additional components may require, that I will do. And second thing, then harmonics, that and all I can able to do it here. Okay, I can able to do it here. Okay, so then step three, That's it. Step three. Once it was then step three, when means get an approval. Up until approval, we are the responsible. Okay, get an approval from the utility for the simulation models. Okay, simulation models. Okay, then step four. This is completely technical. Okay, it's fully pakka technical. Fully technical discussion may happen. Then step four. That's it. As I told, the commissioning. Okay, commissioning team should come to the picture. Here they will do discuss with the SCADA protections. Everything they will do it here. Okay. Then step five, they will go for the testing in line with the step three. Okay, in line with the step three. Okay, step three, and after that, if everything is goes very well, then plant has been energized. That's it. So these are the basic steps that we do have. Suppose if any steps is missing, then we need to jump out the previous steps. That's the thing. Okay, if any step was missing. Yeah. I someone I denied who added? Someone has been added. I'm sorry. Someone is joined. Okay. After testing, I think one of the last step is model tuning. Yes, actually, that's possible. After testing, suppose if the results are not coming as per the simulation software, then again the model tuning may require. You got it, now. You got it, now. So it's possible. So when this particular thing is there means suppose in I have give the some simulation results. Okay. So the testing people can able to do the simulation results as per the report given through the simulation. Suppose if it is not but some results are not benchmarking. Simulation is coming some results, but our 10 megawatt is coming in simulation, but the 12 megawatt is coming in testing means something is wrong. So at the time we can try to means try to in line with both the things to be make it 10 megawatt or make it 12 megawatt. That we need to. So which is correct as per the methodology, as per technical thing. Then in that way we have to go in as per that particular way. Okay, that's right. You're right. You're right. If required, we can able to go for model trading. Suppose no everything is goes well means then it will not be do that. Okay. As I told, if suppose anything is not validated, then again we need to go to the previous steps. After is the testing is in line should be in line with okay testing should be in line with the step three. If not, the tuning is required. Okay, I can put it be in line with step three. If not, model tuning may require. Okay. So now what we are going to do? We are in a step two only. Okay. We are not going to do the. This is our step. Okay. This is the thing that we are going to do. So we are in a step two. Okay. I hope this is clear. This is the thing we are going to do it right now. Okay. This is the thing we are going to do it right now. Yeah. So then the design layout, everything will be given by the design team. So maybe we can able to say we can give some designation also. This is called a design engineer or design engineer will do, or else we will get something sales engineer also. I'm just in our organization we are mentioned the sales engineer. We can support this as power system engineer, and this is I think you think you can know about right. This is a common electrical engineer that should come, and yeah, apart from that, everything should be on comes under the electrical engineering group, right? Electrical engineering or testing and commissioning engineer. So in day to day, they will tell like that, but this is the most probably designation they do have it actually at the time. So maybe step six or steps. They will do that. Maybe maybe in your organization maybe differs. In my organization maybe differs, but in step two is a completely power system engineer only. Okay, no, apart from power systems, we can't. Nobody can able to do that. Those particular studies. Okay, a B triple E maximum be there. Maybe they will do it, and maybe power systems will be a more advantageous. Maybe any power electronics also we can able to the people's having an opportunity to do that, but very less compared to power system engineer. They do have an options which is very less actually. Yeah. So yes. So once it was done, what we are going to do the next step. Now step two is my priority. Just go to the PSE means that means power system studies. Okay, power system studies in software. That is that what we are going to do first. So already what is the thing? Then they have designed the plant, right? So here they are already designed the plant, different the layout, number of inverters, tape, transformer rating, everything they will giving to me. Okay, that means we are going to collect the details. The first step is collect the details of the plant. That's simple. Your job is only first step is to collect the details. The where you should not design. Okay, you are going to collect the details from the previous one, previous guys, previous step one. Okay, that is you have to going to collect the inputs. That is called a basic plant inputs, basic plant level inputs, plant level inputs. They will have okay plant level inputs. So here once you have collected we are this is a very very most important step. This is a very very basic and very important that we are going to do. So once you have get all the inputs from the particular design team, you are going to implement that particular hardware means that is SLD single line diagram or that thing, everything what they are going to give, that we are going to convert into the simulation, that we are going to convert the particular SLD everything parameters, transformer rating, transformer Z, cable rating, cable R and XV values, everything will be going to be connect inside the software. That is a quite tedious task, and that is a very important task also for the power system. So this is a very important thing that we that the rest it is then convert the given inputs into the respective simulation. That is maybe how I can able to say that is called power system network modeling. Okay? This is called modeling. So this is a very very important step. Suppose if you are if anything small, simply if you are missing something, that's it gone. Everything will be get collapsed. So I strongly recommended to you to do that. You have to be more conscious on this particular step. Even though the studies we can able to perform very well, but the thing is, if the modeling was wrong, everything, then we are it was gone. So our most important step is to do that, to do the simulation step, and third step, and performing the studies and perform the required studies. Required studies once it was done. I hope this is the scope, this is the flow of work that we are going to have correctly. Okay, so now what we are going to do in the classes means I'm just going to. So this is the basic steps we are doing that. So now from where we are going to start, I am going to start from the modeling perspective point of view. In all the softwares, three different softwares you do have, right? PSSE, PSCAD, ETAP. In all the different softwares, how I am going to convert the generated details into the simulation. How I'm going to convert the transformer details into the simulation. How I'm going to convert the cable details simulation. How it is converting. Okay, I'm converting. I converted and I just modeled. How can you able to tell whether it is right or wrong? Also, we need to validate, right? That means power system validate modeling and validation. Validation of the well, both is important. I need to validate how I'm trusting you. Okay, how I'm trusting whether it is right. You can able to enter whatever the value you can do, but how say it is correct. Right? We need that. That is a validation is more important. Modeling we can do anything. Okay, I have to enter R value here. You can able to enter 0.009875. Any value I can able to enter, but how this value arises? Yeah, as per so this can be able to calculate it. For example, this has to be calculated by the electrical electrical theory. Electrical theory only. We are going to use basic electrical theories. Okay, basic electrical theories like for example, Ohm's law is a basic electric. Maybe that's I'm just saying. Okay,